Ruby is a dynamic, reflective, object-oriented, general-purpose programming language. It was designed and developed in the mid-1990s by Yukihiro Matsumoto in Japan. According to its creator, Ruby was influenced by Perl, Smalltalk, Eiffel, Ada, and Lisp. It supports multiple programming paradigms, including functional, object-oriented, and imperative. It also has a dynamic type system and automatic memory management. History. Early concept Ruby was conceived on February 24, 1993. In a 1999 post to the Ruby Talk mailing list, Ruby author Yukihiro Matsumoto describes some of his early ideas about the language. I was talking with my colleague about the possibility of an object-oriented scripting language. I knew Perl, but I didn't like it really, because it had the smell of a toy language. The object-oriented language seemed very promising. I knew Python then, but I didn't like it, because I didn't think it was a true object-oriented language. OO features appeared to be add-on to the language. As a language maniac and OO fan for 15 years, I really wanted a genuine object-oriented, easy-to-use scripting language. I looked for, but couldn't find one, so I decided to make it. Matsumoto describes the design of Ruby as being like a simple Lisp language at its core, with an object system like that of Smalltalk, blocks inspired by higher-order functions, and practical utility like that of Perl. The name Ruby originated during an online chat session between Matsumoto and Keiji Shitsuka on February 24, 1993, before any code had been written for the language. Initially 2 names were proposed, Coral and Ruby. Matsumoto chose the latter in a later email to Shitsuka. Matsumoto later noted a factor in choosing the name Ruby: it was the birthstone of one of his colleagues' first publication. The first public release of Ruby 0.95 was announced on Japanese domestic newsgroups on December 21, 1995. Subsequently 3 more versions of Ruby were released in 2 days. The release coincided with the launch of the Japanese-language Ruby List mailing list, which was the first mailing list for the new language. Already present at this stage of development were many of the features familiar in later releases of Ruby, including object-oriented design, classes with inheritance, mixins, iterators, closures, exception handling and garbage collection. Early releases following the release of Ruby 0.95 in 1995, several stable versions of Ruby were released in the following years. Ruby 1.0, December 25, 1996. Ruby 1.2, December 1998. Ruby 1.4, August 1999. Ruby 1.6, September 2000. In 1997, the first article about Ruby was published on the web. In the same year, Matsumoto was hired by Netlab.jp to work on Ruby as a full-time developer. In 1998, the Ruby Application Archive was launched by Matsumoto, along with a simple English language homepage for Ruby. In 1999, the first English-language mailing list Ruby Talk began, which signaled a growing interest in the language outside Japan. In this same year, Matsumoto and Keiji Shitsuka wrote the first book on Ruby, the object-oriented scripting language Ruby, which was published in Japan in October 1999. It would be followed in the early 2000s by around 20 books on Ruby published in Japanese. By 2000, Ruby was more popular than Python in Japan. In September 2000, the first English-language book Programming Ruby was printed, which was later freely released to the public, further widening the adoption of Ruby amongst English speakers. In early 2002, the English-language Ruby Talk mailing list was receiving more messages than the Japanese-language Ruby list, demonstrating Ruby's increasing popularity in the English-speaking world. Ruby 1.8 Ruby 1.8 was initially released in August 2003, was stable for a long time, and was retired June 2013. Although deprecated, there is still code based on it. Ruby 1.8 is only partially compatible with Ruby 1.9. Ruby 1.8 has been the subject of several industry standards. The language specifications for Ruby were developed by the Open Standards Promotion Center of the Information Technology Promotion Agency for submission to the Japanese Industrial Standards Committee and then to the International Organization for Standardization. It was accepted as a Japanese industrial standard in 2011 and an international standard in 2012. Around 2005, interest in the Ruby language surged in tandem with Ruby on Rails, a web application framework written in Ruby. Rails is frequently credited with increasing awareness of Ruby. Ruby 1.9 Ruby 1.9 was released in December 2007. Effective with Ruby 1.9.3, released October 31, 2011. Ruby switched from being dual-licensed under the Ruby license and the GPL to being dual-licensed under the Ruby license and the two-clause BSD license. Adoption of 1.9 was slowed by changes from 1.8 that required many popular third-party gems to be rewritten. Ruby 1.9 introduces many significant changes over the 1.8 series. Examples: block local variables, an additional lambda syntax, f equals 2, puts a plus b. Per string character encodings are supported. New socket API. Require _relative import security. Ruby 1.9 has been obsolete since February 23, 2015, and it will no longer receive bug and security fixes. Users are advised to upgrade to a more recent version. Ruby 2.0 Ruby 2.0 added several new features, including method keyword arguments, a new method module #prepend for extending a class, a new literal for creating an array of symbols, new API for the lazy evaluation of enumerables, and a new convention of using #to to convert objects to hashes. Ruby 2.0 is intended to be fully backward compatible with Ruby 1.9.3. As of the official 2.0.0 release on February 24, 2013, there were only 5 known incompatibilities. Ruby 2.1 Ruby 2.1.0 was released on Christmas Day in 2013. The release includes speed-ups, bug fixes, and library updates. Starting with 2.1.0, Ruby's versioning policy is more like semantic versioning. Although similar, Ruby's versioning policy is not compatible with semantic versioning. Semantic versioning also provides additional labels for pre-release and build metadata are available as extensions to the major, minor, patch format. Not available at Ruby. Ruby 2.2 Ruby 2.2.0 was released on Christmas Day in 2014. The release includes speed-ups, bug fixes, and library updates and removes some deprecated APIs. Most notably, Ruby 2.2.0 introduces changes to memory handling, an incremental garbage collector, support for garbage collection of symbols and the option to compile directly against gmalloc. It also contains experimental support for using vfork with system, and added support for the Unicode 7.0 specification. Features that were made obsolete or removed include callcc, the DL library, digest, HMAC, lib/rational.rb, lib/complex.rb, gserver, logger, application as well as various C API functions. Ruby 2.3 Ruby 2.3.0 was released on December 25, 2015. A few notable changes include the ability to mark all strings literals as frozen by default with consequently large performance increase in string operations. Hash comparison to allow direct checking of key-value pairs instead of just keys. A new safe navigation operator and that can ease nil handling. hashtag dig an array hashtag dig to easily extract deeply nested values equals greater than foo bas grep underscore v, which will match all negative examples of a given regular expression in addition to other new features. The 2.3 branch also includes many performance improvements, updates, and bug fixes, including changes to proc hashtag call, socket and IO use of exception keywords, thread hashtag name handling, default passive net, FTP connections, and rake being removed from stdlib. Philosophy. Matsumoto has said that Ruby is designed for programmer productivity and fun, following the principles of good user interface design. At a Google Tech Talk in 2008, Matsumoto further stated, "I hope to see Ruby help every programmer in the world to be productive, and to enjoy programming, and to be happy. That is the primary purpose of Ruby language." He stresses that systems design needs to emphasize human, rather than computer, needs. Often people, especially computer engineers, focus on the machines. They think, by doing this, the machine will run fast. By doing this, the machine will run more effectively. By doing this, the machine will something. They are focusing on machines. But in fact we need to focus on humans, on how humans care about doing programming or operating the application of the machines. We are the masters. They are the slaves. Ruby is said to follow the principle of least astonishment, meaning that the language should behave in such a way as to minimize confusion for experienced users. Matsumoto has said his primary design goal was to make a language that he himself enjoyed using, by minimizing programmer work and possible confusion. He has said that he had not applied the principle of least astonishment to the design of Ruby, but nevertheless the phrase has come to be closely associated with the Ruby programming language. The phrase has itself been a source of surprise, as novice users may take it to mean that Ruby's behaviors try to closely match behaviors familiar from other languages. In a May 2005 discussion on the newsgroup comp.lang.ruby, Matsumoto attempted to distance Ruby from Polar, explaining that because any design choice will be surprising to someone, he uses a personal standard in evaluating surprise. If that personal standard remains consistent, there would be few surprises for those familiar with the standard. Matsumoto defined it this way in an interview: "Everyone has an individual background. Someone may come from Python, someone else may come from Perl, and they may be surprised by different aspects of the language. Then they come up to me and say, 'I was surprised by this feature of the language.' So Ruby violates the principle of least surprise." Wait. The principle of least surprise is not for you only. The principle of least surprise means principle of least my surprise, and it means the principle of least surprise after you learn Ruby very well. For example, I was a C++ programmer before I started designing Ruby. I programmed in C++ exclusively for 2 or 3 years. And after 2 years of C++ programming, it still surprises me. Features: thoroughly object-oriented with inheritance, mixins and metaclasses, dynamic typing and duck typing. Everything is an expression and everything is executed imperatively. Succinct and flexible syntax that minimizes syntactic noise and serves as a foundation for domain-specific languages. Dynamic reflection and alteration of objects to facilitate metaprogramming. Lexical closures, iterators and generators, with a unique block syntax. Literal notation for arrays, hashes, irregular expressions and symbols. Embedding code in strings. Default arguments. 4 levels of variable scope denoted by sigils or the lack thereof. Garbage collection. First-class continuations. Strict Boolean coercion rules. Exception handling. Operator overloading. Built-in support for rational numbers, complex numbers and arbitrary precision arithmetic. Custom dispatch behavior. Native threads and cooperative fibers. Initial support for Unicode and multiple character encodings. native plugin API in C, interactive Ruby shell, centralized package management through Ruby gems, implemented on all major platforms, large standard library, including modules for YAML, JSON, XML, CGI, OpenSSL, HTTP, FTP, RSS, curses, zlib, and TK. Semantics. Ruby is object-oriented. Every value is an object, including classes and instances of types that many other languages designate as primitives. Variables always hold references to objects. Every function is a method and methods are always called on an object. Methods defined at the top-level scope become members of the object class. Since this class is an ancestor of every other class, such methods can be called on any object. They are also visible in all scopes, effectively serving as global procedures. Ruby supports inheritance with dynamic dispatch, mixins and singleton methods. Though Ruby does not support multiple inheritance, classes can import modules as mixins. Ruby has been described as a multi-paradigm programming language. It allows procedural programming, with object orientation or functional programming. It has support for introspection, reflection and metaprogramming, as well as support for interpreter-based threads. Ruby features dynamic typing, and supports parametric polymorphism. According to the Ruby FAQ, the syntax is similar to Perl and the semantics are similar to Smalltalk, but it differs greatly from Python, non-primary source needed, syntax. The syntax of Ruby is broadly similar to that of Perl and Python. Class and method definitions are signaled by keywords. In contrast to Perl, variables are not obligatorily prefixed with a sigil. When used, the sigil changes the semantics of scope of the variable. One difference from C and Perl is that keywords are typically used to define logical code blocks, without braces, in other words a pair of and. For practical purposes there is no distinction between expressions and statements. Line breaks are significant and taken as the end of a statement. A semicolon may be equivalently used. Unlike Python, indentation is not significant. One of the differences of Ruby compared to Python and Perl is that Ruby keeps all of its instance variables completely private to the class and only exposes them through accessor methods. Unlike the getter and setter methods of other languages like C++ or Java, accessor methods in Ruby can be created with a single line of code via metaprogramming. However, accessor methods can also be created in the traditional fashion of C++ and Java. As invocation of these methods does not require the use of parentheses, it is trivial to change an instance variable into a full function, without modifying a single line of code or having to do any refactoring. Achieving similar functionality to C# and VB .NET property members. Python's property descriptors are similar, but come with the trade-off in the development process. If one begins in Python by using a publicly exposed instance variable, and later changes the implementation to use a private instance variable exposed through a property descriptor, code internal to the class may need to be adjusted to use the private variable rather than the public property. Ruby's design forces all instance variables to be private, but also provides a simple way to declare set and get methods. This is in keeping with the idea that in Ruby, one never directly accesses the internal members of a class from outside the class. Rather, one passes a message to the class and receives a response. See the examples section below for samples of code demonstrating Ruby syntax.